All right, let's get going with our starter. Hopefully you've had a chance to go through the 5 questions. So let's get to some answers. When leaves rot on the ground, it is said that they decompose. So you would have marked that true or false. What is the atomic mass of Cl2? Make a choice there. If we start with water and make it decompose, what do we get? Number 4, if we decompose water, what limits the reaction? And the last one, if we decompose 90 grams of lithium chloride, how much lithium and how much chlorine are produced? All right, so I'm going to zip on over to my iPad and we'll get going here. All right, let's get started. So, number 1 said when leaves rot on the ground. Wants to know about that word decompose. Decompose does mean to rot, okay, which with leaves and other things it means to break apart. Okay, break apart, decompose. So we're going to break things up this time. Decomposition, decompose. So that was true. Okay, number 1 was true. All right, number 2, atomic mass of Cl2. As I look through the answers on your stoichiometry problems, one of the things that I probably leave more comments on than anything else is making sure that you're adding up those atomic masses right. So Cl2, let's zip on over here. I'm going to clear this page a little bit and then zip on over here to chlorine. So chlorine right here, one of them is 35. Okay, that's a single Cl, a single chlorine. Just like a single sulfur right next to it is 32, or a single fluorine above it is 19. So if we have a 2, okay, Cl2, that means that there are 2 of them, Cl plus Cl, which is going to be 35 plus 35, which is going to be 70 grams, okay? Cl2 is 70 grams. All right, number 3. If we start with water and make it decompose, what do we get? So if we have H2O, and we're going to make it rot, we're going to make it fall apart, we're going to break it apart, well, it's made up of 2 things, hydrogen and oxygen. So we're going to get hydrogen and oxygen, but, so if you wrote H and O, you're halfway there. Remember, step 3 in that stoichiometry process, you've got to remember the diatomics. If they're by themselves, they always got to have that little 2 behind them because hydrogen and oxygen are both diatomic. So the correct answer for that would have been answer B. Okay, H2 and O2. All right, number 4. In this reaction, if we have H2O and it is going to fall apart into H2 and O2, we need to balance that. So let's see. That would give us 2 of those, 2 of those, and 1 of those. So if that's our final balanced reaction, what limits the reaction? Well, remember, when we run out of reactant, that's when the reaction stops, right? When we run out of reactant. Well, in this case, we only have 1 thing. So when we run out of our 1 thing, it stops, it's limited. And so that's like eating pancakes. You're eating pancakes and you're chomping them up and your tummy's breaking them down. So what limits that process? How many pancakes your mama made. So, yeah, what limits it is this thing, the amount of water present. Okay? All right, number 5, let's do a little stoichiometry. So step 1, write the reactant. Well, in this case, we only have 1, and it is lithium chloride. It's going to break apart. It's going to break apart into its 2 elements, lithium and chlorine. So that was step 2. We wrote the products. Step 3, do diatomics. Well, let's see, in this case, chlorine's diatomic. On the right side, it's traveling by itself. It's got to have a 2. Lithium's not diatomic, and the chlorine with the lithium already traveling with a friend. No need for a 2. All right, let's go ahead, balance the molecule. In this case, lithium, chlorine, both +1, -1. The ones cancel. LiCl is perfect. I'm going to add some lines here so we can balance this. Hopefully you're going to agree with me. Our coefficients are 2, 2, and 1. So 2 lithium chlorides plus 2 moles of lithium plus 1 mole of chlorine. So 2 moles of lithium chloride produce 2 moles of lithium plus 1 mole of chlorine in a decomposition reaction. All right, next step. We're still going to do just what we did before. We're going to draw some lines. 2 below, 1 above. The ones above are labeled moles. Boy, look, no difference. What you already learned, you can apply right from here. There we go, grams down below, same as before. This is the given, and this is the atomic mass. I'm going to abbreviate that AM, atomic mass. All right, in this case, we're just going to go and look at what we were given. And I told you you were given 90 grams. All right, let's go figure out some atomic masses. LiCl. We've got to go back over to here, to our periodic table. And there's lithium, 6.94. We're going to call that 7. And chlorine on the other side over here, we already looked that one up, and it's 35. All right, so let's go all the way back across. All right, so lithium and chlorine. We have 1 lithium, so that is 7. 1 chlorine for 35, so that is 42 for an atomic mass. Over here, we only have 1 lithium, so that is 7. On our last one, we have chlorine, but Cl2, so that is 35 plus 35, or 70 grams for 1 mole. Okay, next steps. We do just like we did before. We do a little bit of division here. 90 divided by 42. And if you got your calculator out, you would find that that is 2.143. Notice I'm holding on to a few digits there to make sure that I keep my accuracy. All right. I'm going to use this one because it's the only one I have. I know it's limiting. So 2.143 over 2 equals, there we go, x. No, we're doing the same thing, right? Equals x over 2. And so that one is 2.143. And we'll do that one more time. I'll use y over here this time. 2.143 over 2 equals y over 1, right? Y over 1. And if you do that little cross multiplication, you're going to find it is 1.07. One last step, we just have to do some multiplication of that times 7, that times 70, and 2.143. So 2.143 times 7 is going to be 15. And 1.07 times 70 is going to be 75. Notice if we take the 15 and the 75, I'm going to circle those, that adds up to 90. Conservation of mass. When we break that water down, when we break that lithium chloride down, it has to add up to what we started with. All right, so that's our starter for today.